Okay, let's start the solution of this paper. There are two solid metal spheres. Okay, you can draw two spheres here, the big one and the small one. And the ratio of the total surface area of small sphere to the surface area of the larger sphere is 16 to 25. Okay, and the radius of the larger sphere is 10 cm. So part A, expressed in terms of pi, the volume of the smaller sphere. Now we can let R be the radius of the smaller sphere. As you know, these two spheres are similar figures. So if you want to find the radius of the smaller sphere, you can use the concept of ratio of similar figure. That is, when you consider the length ratio of two similar figures and then you take square, then will equals to the area ratio. Okay, so that's the notes for two similar solids. Length 1 over length 2 bracket square, the square of the length ratio will equals to their area ratio. And when you consider the length ratio and then take cube, it will equal to their volume ratio. Okay, and here you need to find out. So both sides taking square root, then you get 4 over 5. Of course you will not consider the negative number, so R here, that is 8. When you get R equals 8, then you can find volume of the smaller sphere. That will be 4 over 3 times pi times 8 to the power 3 cm cube. And you need to leave the answer in terms of pi, so you can press it 4 over 3 times 8 to the power 3. You get such decimals. You press the fraction button. That's 2048 over 3. And then pi cm cube. So that's finished part A. And go to part B. The two spheres are melted and we cut, that means we form, okay, into two solid right circular cones. From two spheres becomes two cones. Denote these two circular cones by A and B, okay, cone A and cone B. It is given that the height and the base radius of A are 42 cm and 4 cm respectively. A student finds that the base radius of B is 8. So you can see in this situation, the cone B, it seems the base radius is bigger than A. So we may try to draw some figure like this. Originally there are two spheres. One of the radius is 8 and other radius is 10. And it becomes to two cones. There's a cone A and there's another cone B. The base radius of cone A is 4, the height 42, and the base radius of cone B is 8. Of course, we don't know the height. Now, the student claims that these two solids, A and B, are similar. Do you agree, or is the claim correct? Okay. If you want to check whether two solids are similar, you need to check their length ratio, take cube, whether it is equal to their volume ratio. You need to compare these two values. If these two values are equal, then these two solids are similar. Okay, so you need to try your best to find the volume of this cone. Okay, what we can do is you can use the observation, that is the volume of two spheres equals the volume of these two cones. So we can write something like this. Volume of spheres equals to volume of cones. Alright, so you can set up the equation here, that is 2048 over 3 times pi plus 4 over 3 times pi times 10 to the power 3, that is the volume of two spheres, equals 1/3 times pi r squared times height, that is the volume of cone A. Okay, and plus another value B. We let B as the volume of cone B. So let's plug in the number here. Okay, let's plug in the number here. 2048 divided by 3 plus 4 over 3 times 10 to the power 3, that's 2016. So left hand side, 2016 pi and for this one, 1 over 3 times 4 squared times 42, that you will get 224 plus B. B is the volume of cone B. Okay, so small letter b equals to 2016 pi minus 224. That is 1792 pi. That is the volume of cone B. And next, we are going to check the volume of A over volume of B. That is 224 pi over 1792 pi. Do the cancellation using calculator. Pi can be cancelled, and you simplify this fraction, you will get 1 over 8. So this is the volume ratio. Okay. And next, you need to check the length ratio. Radius of A over radius of B. But that's just the length ratio. You need to check the cube of the length ratio and see whether it is equals to the volume ratio. Okay. So that is 4 over 8 and then bracket to the power 3. And luckily you will find it's 1 over 8 again. So you see that these two ratios are the same. The length ratio to the power 3 equals to the volume ratio. Therefore, you can say A and B are similar. And the claim is correct. Okay, you can correct. Okay, say the claim is correct. So that's finished the first question, and then go to second question. For the second question, that is the question about more about polynomial. So let P be a cubic polynomial, x cubed plus ax plus b. A, b are constants, and px is divided by x squared minus x plus 1. The remainder is this one. So if you really forgot the relationship among those polynomials, don't worry. Let's write down some basic numbers at the beginning. Suppose 7 is divided by 3. Then the top position we will put 2, right? So 3 times 2, that is 6. And the number at the bottom is 1. We call the number 2 here is quotient. Quotient, quotient. And the number at the bottom is remainder. Okay. So how do we write these numbers in the form of equation? 7 can be written as 3 times 2 plus 1. 7 equals to 3 times 2 plus 1. Okay, follow the position. So what's happened when you are working with the polynomial? Similar. When px is divided by x squared minus x plus 1, then you will have something at the top described as a quotient. After a long calculation, you will get the remainder negative 7x plus 5. Therefore, you can also present in this way. The polynomial px, actually that's equals to x squared minus x plus 1 times a quotient qx, and then plus the remainder negative 7x plus 5. That's the way you can express all these functions horizontally. Write down all this in the form of equation. So go back to this question, then you can see that the px can be written as a divisor x squared minus x plus 1, and here there's a quotient, and then plus the remainder. The problem is, what is the quotient? The format of the quotient. Try to think. When x cubed is divided by x squared, the first term of the quotient would be x only. And how do we get this x? That is x cubed divided by x squared. Okay? You need to look at the function here. Sometimes it may be 2x cubed when it's divided by x squared, so the quotient will be 2x. Okay? Just doing the division of the first two leading terms. Okay? The first term of the dividend, the original polynomial, and the first term of the divisor. Okay? Do the division and you can get the first term of the quotient. How about the second term of the quotient? You really don't know, so you can give a constant plus small letter c. Okay? C is a constant you need to find out. So you can treat this one as a identity. You can treat this one as an identity, and you can expand all the bracket and group in the like terms. Hence, you can compare the like terms on both sides. X cubed plus ax plus b equals x cubed plus cx squared minus x squared minus cx plus x plus c minus 7x plus 5. So next step, you will simplify something like this. Of course, you have x cubed and cx squared minus x squared, that is c minus 1 bracket x squared. Okay, there's a hidden 1 in front of x squared. And next, plus negative c plus 1x minus 7x, so minus 6x. Finally, the constant term c plus 5. Now you can compare the coefficient. Okay, b equals c plus 5. ax equals negative c minus 6. And how about c minus 1x squared? On left hand side, it seems no x squared term. So you can think in this way. That is plus 0 times x squared. Okay? Hence, you can compare the like terms on both sides of the equation. 0 would equals c minus 1. C is 1. And next, a equals to negative c minus 6. A is negative 7. Finally, b equals c plus 5, and hence b equals 6. So that's the end of part A. And move to part B. Is x plus b a factor of px? So let's think in this way. Suppose px is divided by x plus 3, and there's another quotient you should have the remainder basically, but you don't know the value of the remainder, right? And the meaning of the factor means when you are doing the division by using this polynomial, it should have no remainder. So the target is you want to show whether R equal to 0. Whether R equal to 0. If R equal to 0, okay, you just cover it. You can see Px equals to x minus 3 times this Q1x. It is a factor form, okay? So try to think, in this equation, you can treat this one as an identity, as I said. You can change or you can substitute any value of x in this equation or in this identity. So which number you will choose? Of course, the only choice will be x equals negative 3. Because when x equals other number, you did not know how to simplify Q1x. The only way to remove Q1x is you put x equals negative 3. So when you put x equals negative 3, you will get the remainder will be R, because negative 3 plus 3 equal to 0. So that's why we sometimes set x plus 3 or this divisor be 0 and try to find out what is the value of x. So you need to do is calculate p negative 3 and see whether it is equal to 0. Negative 3 to the power 3 minus 7 times negative 3 plus 6. That's negative 27 plus 21 plus 6. Luckily that is 0. That means the remainder is 0 here. And go back to the original statement, R equal to 0. So x plus 3 is a factor. Therefore, x plus 3 is a factor of Px. So let's finish part B. And go to part C, look at the question. Someone claims that the equation Px equal to 0 has two irrational roots. Do you agree? Explain your answer. Of course, we can try to solve the equation directly and see what is the root of the equation. But we need to look what is the meaning of irrational number. In some numbers, it cannot become a fraction. And what is fraction? That is a number become a p over q, and pq are integers. Okay? So for example, square root 2 cannot become a fraction. You won't say 1 over root 2 or root 2 over 2 is an rational number. No, because square root 2 originally it is not a rational number. Okay, so even though you put it in the denominator, it would not become a rational number. Okay, for example, square root 3, pi, sine 18 degree, and so on. Such kind of number are not rational roots. Okay, are not rational numbers. Okay, how about a rational number? For example, 3, 6, 12 over 7, negative 4, 0. Okay, such kind of integer or fraction, we'll call all these are rational numbers. So go back here, let's try to solve the equation. X cubed minus 7x plus 6 equal to 0. When it is divided by x plus 3, then you can find that the remainder is 0. That means x plus 3 is a factor of this polynomial Px. So how do we find the first term of the quotient? X cubed divided by x, that's x squared. Okay, you can find this one. X cubed divided by x, and you get x squared. And how about the constant term? 6 divided by 3, you get positive 2. So here, how would you get this? Positive 6 divided by positive 3, you get positive 2. And how about the middle one? Middle one, that's a little bit clumsy. You need to think, how do we get this negative 7x? In here, it should be something x, right? But you don't know what is the number here. So let's see, how could this negative 7 comes from? It is contributed by two parts. The first part is x times 2, right? X times 2. The second one is this 3 times this unknown x plus 3 times something question mark, okay, x. So what you need to find out is this question mark. Negative 7 equals to 2 plus 3 times some number. So this number will be negative 3. And hence, here you put negative 3 here. After you write this, you can see that there's other quadratic expressions here. Use cross method to do it again, if possible. X plus 3 bracket x minus 1, x plus 2, sorry, x minus 2. You will find that all these 3 terms, the product is 0. That means either one of them will be 0, and therefore the answer will be x equals negative 3, or x equals 1, or x equals 2. All these are rational. Negative 3, 1, and 2 are all rational. Therefore, the claim is not agreed. There is no irrational root. All roots are rational. Okay? So that's the end of question number 2. And go to question number 3. There is some questions about sum and product of root of the quadratic equation. A quite standard one. Suppose alpha and beta are the roots of this quadratic equation. In here, you can see it's already a standard form. So-called the A, that is coefficient of x squared, that is h, and the coefficient of x, that's called b, that is positive 1. And c, that's the constant term, is also 1. So a, b, c are stated very clearly, and h is a non-zero constant. That means h cannot equal to 0. Part A, evaluate this fraction 1 over alpha plus 1 over beta. If you really forgot how to start with, okay, you always try some simple number. For example, 1 over 3 plus 1 over 5. What would you get? In denominator, that is 3 times 5. And numerator, 1 times 5, 5. Plus 1 times 3, 3. Okay, that's the expressions. So you are doing the same thing in the 1 over alpha plus 1 over beta. Alright? You get alpha times beta in the denominator, and then beta plus alpha in the numerator. And next, that's the key. When you are considering the sum of root and product of root, you are applying the formula alpha plus beta equals to negative b over a. So in here, there should be negative 1 over h. And when you are considering the product of alpha times beta, there will be constant term c over a. So that is positive 1 over h. Therefore, this one, beta plus alpha over alpha times beta, can be simplified as negative 1 over h over 1 over h. And you find that these two numbers are exactly the same, so you will simplify as negative 1. So that's finished. Question number A. And part B, find the range of h so that alpha and beta are real and distinct. When you look at these two roots are real and distinct, quite standard. You want the discriminant greater than 0. Two distinct roots, okay? You want the discriminant greater than 0. So b squared minus 4ac greater than 0, okay? That's the expressions. Discriminant greater than 0. 1 squared, that's 1, and then minus 4h greater than 0. So you should move 4h to another side, and then divided by 4. Finally, put h on left hand side, h less than 1 over 4. And you find that h less than 1 over 4, then the root of this equation will be real and distinct, right? Therefore, this is the possible range we want to find out. But don't forget, h cannot be 0. Therefore, your final answer is h less than 1 over 4 and h is not equal to 0. Okay, you should state very clearly. So that's the end of part B using concept of delta. So part C, the question gives you the relationship between alpha and beta. h cubed times beta squared minus h squared times beta equals -2. Find h. The problem is you find out the power of two roots are not the same. The power of two roots are not the same. Therefore, you need to change their power. Okay, reduce this power. But how? Let's go back to the equation. Since alpha is the root of this equation, x squared plus x plus 1 equal to 0. Okay, that means when x is replaced by alpha, the equation still works, right? And we can see in this way. Then h alpha squared would equal to negative alpha minus 1. So what we can do is, when you use this equation, you multiply h squared on both sides. Why? Because there's an h cubed alpha squared in the question. So you want to create something like h cubed alpha squared here, and right hand side h squared alpha with a negative sign minus h squared. Therefore, you can substitute in the equation here. For part C, h cubed alpha squared minus h squared beta equals -2. We use this relationship, substitute in here. Therefore, negative h squared alpha minus h squared beta equals to -2. And you find that all terms in the equation are negative. So you can multiply all terms by -1 to change back to positive. And hence, h squared alpha plus h squared beta equals +2. So group the like terms. h squared bracket alpha plus beta plus h squared minus 2 equal to 0. And you find that alpha plus beta, as you see, that is -1 over h. Okay? So h squared multiplied -1 over h plus h squared minus 2 equal to 0. So h squared minus 2 equal to 0, and luckily you can set up the quadratic equation here. H squared plus h minus 2 equal to 0. So h plus 2 times h minus 1 equal to 0, you will get two answers. H equals -2 or h equals +1. And h equals +1 should be rejected. Why? Because h should be less than 1 over 4, as we discussed. Okay? So that's the final answer. H equals -2. If you have no problem, let's move to the fourth question. There's the question about the quadratic graph. Let's see be a quadratic graph of y equals a bracket x plus h bracket squared plus 1. A and h are negative constant. It is given that the y-intercept of the graph C is above the x-axis. That means y-intercept is positive number. Okay? So A, show that this one. You can see something related to A and H. So we use this condition. A. We find the coordinates or we find the numbers of y-intercept, okay? Substitute x equal to 0 into equation. Then you will get the y coordinate will be a bracket 0 plus h all square plus 1, y equals to ah square plus 1. And remember, this square just gives to h only. As you know that this is y coordinate, right? So this y coordinate must be positive. And hence you can do the transposing term now. Make a be subject. Ah square greater than negative 1. And then a greater than negative 1 over h square. You can see that h square is positive because h is negative, so h square will be a positive number. So you can see that a is greater than this number. But at the same time, when you look at this one, a should be negative. That means a less than 0. Also, h is less than 0, so we can focus on a now. So you can make the conclusion that a would lie between 0 and negative 1 over h bracket square. Okay? So that's the end of part A. And part B, find the x-intercept of the graph C. So quite straightforward. You substitute y equal to 0 into equation. So what's the next step? That is, y becomes 0 now. And move positive 1 to another side, become negative 1. So negative 1 over a, that's become x plus h all square. But it seems negative, but no, because a is negative, so the whole stuff is positive. So you can take square root. Negative 1 over a plus or minus in front of it. Because there are two possible answers, one positive square root and other one is a negative square root. So you can find x now, that is negative h plus or minus square root negative 1 over a. There's the x-intercept, okay? Write down the final statement. X-intercepts negative h plus square root negative 1 over a, comma, negative h minus square root negative 1 over a. So that's it. That's finished part B. And then go to part C. You need to write down the coordinate of the vertex of C in terms of h. So go to part C. The graph is y equal to a x plus h all square plus 1. And many of you think that, okay, the vertex is h1. No. If this is positive here, then the vertex will be negative h. And the y coordinate of vertex is just copy this one, 1. So the vertex is negative h, 1. So finally, you need to sketch the graph of this curve C, indicate intercept and vertex. So we have the x-intercept, we have the y-intercept, should be positive, okay? And hence you can sketch the graph now. You have the positive y-intercept, and also look at the sign of the vertex. H is negative, so negative h is positive, and that means vertex will be on right hand side. Also, the y coordinate of vertex is positive. That means it goes up. So vertex is something like here. Negative h, 1. And there's a positive y-intercept. So after you sketch this, it will form something like that. X, y. And this one will be ah square plus 1, the y-intercept. In here, the x-intercept will be negative h minus square root negative 1 over a. And here, the positive x-intercept, negative h plus square root negative 1 over a. Okay? You can look at here. This one must be less than next one, okay? This one must be less than that one, okay? So negative h minus square root negative 1 over a on here, okay? And that is the final answer of this question number 4. So go to question number 5. Again, there's a quadratic graph, but it is quite more related to the completing square. You can see. Let fx be this one. K is a real number, okay? That means the variable is x. Denotes the graph of y equal fx as g, and the vertex of g as v. A, using the method of completing square, express the coordinate of v in terms of k. Alright, so let's start. Fx equals 2x squared plus 12kx plus 20kx plus k squared minus 8k plus 9. As you can see that, you can take out the number 2 here for the first two terms. For the term related to x squared and x, you need to take out the coefficient of x squared. It may not be a common factor, it doesn't matter, just take out the number or the factor of the coefficient of x squared. So 2 plus x squared plus 6kx, and then leave some space here, okay? We want to add something. Plus 20k squared minus 8k plus 9, okay? There's sometimes outside the bracket. And the term inside you need to add, that is, we want to make the perfect square inside. So we need to divide this coefficient of x by 2. That is 6k divided by 2, that's 3k. And then take all square, because you want to make the perfect square at the end. So that is plus 9k squared. You should write down here. But you cannot just add plus 9k squared. You need to minus 9k squared. Okay? Just create a number. Plus 9k squared and then minus 9k squared. So after that, for the first 3 terms, it can be comes to x squared plus 6kx plus 9k squared. And for this negative 9k squared, you multiply by 2. Okay, take it out. So 2 times negative 9, negative 18 plus 20k squared. So there's a plus 2k squared minus 8k plus 9. And hence, you can find this standard format of the perfect square. So x plus 3k all square, and then plus 2k squared minus 8k plus 9. So that is the format of a bracket x minus h plus, I will not use k, okay? X minus p plus q, something like that, okay? So the word has v, it can be written as, in here you see x plus 3y. So the x coordinate of vertex will be negative 3k. And the y coordinate will be, just copy the numbers behind, 2k squared minus 8k plus 9. So let's finish the first part. And part B, the question asks that someone claims that g is always above the x-axis. Is the claim correct? Okay, give reason. So you can see, if I want the graph always above the x-axis, there are some conditions you need to satisfy. The first one, the vertex is always above the x-axis. Okay, that means the y coordinates of v is always positive. But in the situation is, if you just have this one condition, is not enough. Suppose I have the vertex of v, okay, of the graph v is above the x-axis, but if it is open downward, it still not work, right? So the second condition you need to satisfy is open upward. Okay, you need to satisfy these two conditions. So let's check one by one. If you want to check the direction of opening, we check the coefficient of x squared. They're quite straightforward because the coefficient of x squared is positive, or you can say write down that is 2, which is positive. Therefore, the graph G is opened upward. Also, the y coordinate of V, the vertex of graph G, that equals to this one, right? 2k squared minus 8k plus 9. Again, you want this one is always positive. What you can do, you want to check this minimum value is what? If you want to check the minimum value of the quadratic expressions using completing square again. So there's 2 bracket, k squared minus 4k. And inside this bracket, you can add 4 divided by 2, that is 2. You can take 2 squared and then minus 2 squared. Alright, so here that becomes 2 bracket k squared minus 4k plus 4, and 2 times negative 4, negative 8, plus 9, that's plus 1. So there's 2 bracket k minus 2 all square plus 1, okay? Which is always positive. Because even when k minus 2 bracket square is non-negative, it must be non-negative already. It can be 0, yes. When k equals 2, okay, k minus 2 bracket square is 0, okay. But when k is less than 2, for example 1.9, right? 1.9 minus 2, even though you get a 0 negative number, after taking square, it goes back to positive. Alright? So no matter what is the value of k, the first term here is always non-negative. But now you add one more. So that means the whole expression must be positive. And hence, agree, because it is open upward and the y-intercept of the graph is positive, that means the vertex is always above the x-axis. And it keeps smiling face of the graph, that means this graph always above the x-axis. So that one is correct. And next, let's go to question C. Denotes the origin as O. Suppose G cuts the y-intercept at T, something like this. Okay, we can use this graph O, T, okay. Now, express the length of OT in terms of K. Oh, quite straightforward. This one, okay. This one quite straightforward. Because when you sub x equal to 0, then you can find it, okay. So part C, sub x equal to 0 into y equals to x squared plus 12kx, and then let me copy this one, okay. 20k squared minus 8k plus 9, okay, plus 20k squared minus 8k plus 9. So when you substitute x equal to 0, y will become 2 times 0 bracket square plus 12k times 0 plus 20k squared minus 8k plus 9. Okay, so these two terms disappear. So y equals 20k squared minus 8k plus 9. And therefore, the length of OT, there will be 20k squared minus 8k plus 9. Since you know that it is above it, okay, it is above the x-axis, so the y-intercept will also above the x-axis, don't worry, okay. And D, look at the question. Find the least, the smallest possible length of OT and the corresponding value of K. When you see the keyword something like this, least possible length, least possible area of some quadratic expressions, if you need to find some maximum value or minimum value of some quadratic expressions, then using completing square would be the usual method, okay. I suppose you are not using differentiation, okay. if you are applying some basic mathematics in core subject, then you need to use completing square unless you use differentiation. So here, I consider the length of OT, that is 20k squared minus 8k plus 9. In here, remember, you are not take out the common factor of the coefficient of k squared and the coefficient of k, not the common factor. No, you always take out the coefficient of k squared. This is the first priority, so you always take out 20. So it is k squared and then minus 8 over 20. So that is 2 over 5. Okay, and plus 9, you can leave it outside. And next, you need to add a term and then minus a term inside the bracket. So, how do we choose this number? That is, you need to divide it, the coefficient of k, this number, divided by 2. That is negative 1 over 5. You need to divide it by 2. And then take bracket square. So you can do it this way. This number, okay, negative 2 over 5 divided by 2 and then take square. 0.04, what does that mean? 1 over 25. So you need to add 1 over 25 here. When you add this up, you need to subtract it, okay? Plus 9. So the first 3 terms can form the perfect square. And how about this one? This negative 1 over 25, you need to multiply it to 20 and then add with this 9 at the end. So the 8.2, or you can say 41 over 5. So OT can be written as 20 plus k minus 1 over 5 bracket square plus 41 over 5. That's the perfect square format or vertex form. As 20 is positive, that means open upward, so it would have the minimum value, and hence the least value of OT is this one, 41 over 5, okay? When k equals here, if this one equal to 0, then it will be minimum. If k equals 1 over 5, not negative but positive, okay? Because you want to make it as 0. So that's the end of this question, and that's the end of this paper. Thank you so much.